Hi guys, sorry I couldn't be there with you today. I hope you guys had a good Halloween. Today we're just going to do a few things. We're going to give you notes in two small portions. The first one will be on Lewis dot structures, and then I'm going to give you some time to work through your homework a little bit. And then the second will be on ionic compounds, which is what you did essentially in your lab yesterday. I'm just going to review how to name them and how to write them. So as long as we get through both of those things, you'll be able to do all of your homework over the weekend. So you'll be able to do everything in that homework packet. Make sure you guys turned in those labs when you came in today. Those are due today. Okay, I'm pretty new to this iPad program that I'm using, so be patient with me if I have to scroll back at all. Today we're going to start off with, like I said, the Lewis dot diagrams. You guys have already done Lewis dot structures. We did those when we did the quantum theory stuff. So if I outline a periodic table here, you should know that, now I'm running out of room a little bit here, but just picture that there are the 8 groups there. So 1 through 8. The 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. And go ahead and look up on the periodic table, the big one there, and you can see that those are listed as 1A, 2A, and so on. Hopefully you remember from electron configuration that everything in the same group has the same number of valence electrons. The Lewis dot diagrams are the ones where we put dots around the symbol for how many valence electrons it has. So anything in the first group would have 1 valence electron. So 1 dot. Everything in the second group would have 2 dots, or 2 valence electrons. So why don't you pause, go ahead and pause the recording after I give you the examples. I want you to draw Lewis dots for the following elements. Okay. Go ahead and pause right now. Draw Lewis dots for lithium, neon, sulfur, phosphorus, iodine. Once you have those drawn, go ahead and start again and check your answers. Here are my answers. They came up a little bit fast there, but you should see that lithium is in the first group, so it has 1 valence electron. It's in this group. Neon is in the 8th group, so it has 8 valence electrons, or 4 pairs. Sulfur is in the 6th group, so it has 6 valence electrons. Phosphorus has 5, and iodine has 7. We're going to actually use these dots because you know that ionic bonding is between metals and nonmetals, and it's the transfer of electrons. Okay, so it's metals and nonmetals, and then the electrons are transferring. You remember that from yesterday when we said that the electrons transfer from the cations to the anions. So now, instead of having those little cutouts that we used yesterday, we're going to actually move. We're going to see what it looks like when we actually transfer those electrons. Oops, see, sorry, I went a little bit faster. So here we go. That says transfer at the end. Ionic bonding is, again, between metals and nonmetals. The electrons are transferring from the metal to the nonmetal. And that's what I wrote here first on the next page as well. That electrons transfer from the cation to the anion. That's the same thing as saying from the metal to the nonmetal. So I'm going to show you 2 examples of how this works, and then I'm going to have you do 2 examples. So let's say I'm doing sodium and fluorine. Okay, go ahead and put the number of valence electrons, or the dots, around both sodium and fluorine. You should have written in there that sodium has 1 valence electron and fluorine has 7. So what we're going to do is see how the electrons are actually transferred. Now remember, it says that it transfers from the cation to the anion. Cations are metals, and sodium is a metal. So what's going to happen is sodium is going to take its 1 electron and it's going to give it to fluorine. Once it gives it to fluorine, we have to write a second part of the equation, essentially, that tells us what it looks like after that transfer has happened. So we draw an arrow to show what happens. We're left then with sodium with a positive charge because it gave away its 1 electron. And then we're left with fluorine, which now has 8 valence electrons. Whichever one gained the electrons, we draw in brackets so we see where the electrons went. And now all of fluorine has a 1 minus charge. You don't want to forget about that 1 minus charge because fluorine gained that 1 electron. Now, since I'm not there to answer any questions for you, why don't you guys pause the pencast quick and take 30 seconds to explain what we just drew so that the people around you can understand. Okay, go ahead and pause right now. Next example I'm going to show you is if it's not a perfect 1-to-1 ratio. So we're going to do this for magnesium and chlorine. So go ahead and I'm putting right now the dots around magnesium and chlorine. Now look what happens when I transfer that first electron. If I transfer that first electron, this chlorine is now stable with 8, but my magnesium only gave away 1 of its electrons. And remember, that doesn't make magnesium any more stable. It has to give away both of them or neither of them. So if it still has 1 left to give, just like we did yesterday where we had to add in extra puzzle pieces until it became stable, we're going to add another chlorine so the other electron has somewhere to go. Now when we draw our arrow and write what happens afterwards, we have a magnesium that has a positive 2 charge. And now the difference is we have 2 chlorines that each have a 1 minus charge. Okay, so we have 2 chlorines that each have a 1 minus charge. Now we can see from here that, like yesterday, we can figure out what these compounds are. So this one on the top here with sodium and fluorine, this has 1 sodium, 1 fluorine, so it's NaF, which you should know now is named sodium fluoride. This one here is MgCl2 because there are 2 chlorines. Okay, now I want you guys to try 2 on your own. I want you to try calcium and oxygen, and this is nickel and phosphorus, but it should say sodium and phosphorus. I meant Na, not Ni. So put Na instead of Ni. So sodium and phosphorus. Go ahead and pause the pencast and try those 2 and check with the people around you. That should take you a few minutes to do. Now that you've finished, let's take a look at our answers. So the first one, we have calcium and oxygen. I have 6 electrons around the oxygen, and I have 2 on the calcium. This one works out perfectly because calcium wants to give up 2, and oxygen wants to take 2. When I write what it looks like afterwards, I have a calcium 2+ ion, and then an oxygen with a 2- charge. This one would be CaO because it has 1 calcium and 1 oxygen. Next, again, I'll fix this in a second here, but I wrote Ni again, so that should read Na. And there wouldn't be a dot. Let me see if I can erase that. There wouldn't be a dot right there. So we have our sodium is going to transfer 1 of its electrons to the phosphorus, but we notice that there are still 2 unpaired electrons for the phosphorus. So we needed to put 2 more sodiums. Again, these are sodiums, not nickels. Sorry about that. Okay, and they get transferred to the phosphorus also. So now we end up with 3 sodium ions and 1 phosphorus ion, which has a 3- charge. That means that our formula is Na3P. So essentially, this lesson is just to show you how those electrons are actually transferring from the cation to the anion. You guys can work on that page in your homework now.